Hi, welcome to the Calculus 2 lecture series. And this is the first unit for the Calculus 2. We are taking a look at the applications of the integration. And so this is lecture number 2. We are talking about another type of the application for the integration is how to find the volume. From our first lecture, lecture number 1, we used the integration skill and try to find the area, like, for example, bounded by the different curves here. So now, in this lecture number 2, we're going to take a look, how do we find the volumes here? Okay, so now let's go ahead and start. Let me go to our lecture series, lecture notes here. So, okay, so for this lecture, just like we talk about, for this application, the key concept here is let's see, how do we find the volumes, right? So we are going to talk about the two different methods here about how to find the volume. So first one's here, we're going to talk about is determined a volume, okay, of a solid by the slicing method. Okay, then the second part, so the second video for this lecture number 2, we're going to talk about how to find the volume of a solid of a revolution. Okay, so the keyword here is how to find by the slicing methods here. That's what is this lecture we're going to focus on, is how to find the slicing. And then the part 2, we're going to talk about, like sometimes the volume was generated by a function when you're rotating. All right, so when you rotate into a certain line or axis, then you will generate a solid. So that's what we're going to talk about this in our part number 2. Okay, so for the part number 1, so for this video, we're going to talk about how to using the slicing methods here. Okay, so let's take a look at what is the slicing methods here. All right, so for the slicing method here, so I put pictures here. So for examples here, right? So this is let me kind of so like here, this is the thing, this is the solid. Okay, so it doesn't look like a solid, but I think you guys can see. So this is the solid. I want to find I want to find the volume of this solid. So we say, okay, let's slice it. So that's why, I put it like this is kind of a knife. So when you slice it, take a look at this part. When you slice off this solid, is kind of a, so it will be this little kind of like the disc, but not really like a disc, right? Depends on what is the shape. So you can imagine, you can visualize it if you have like a block of the cheese. So just like if this rectangular block of the cheese, and if you want to find the volume of this cheese, what you can do, you can cut into several little slices, and for each slice, you find the volume of this slice, and then you can add those volume together, and then that will be the volume of this cheese, right? And one of the projects that sometimes we will do during the classroom is kind of interesting, the project, and it will give you a banana, right? So it's a banana, I want to estimate the volume of this banana. So what I do here, I can cut the banana into several like slices here. So for each slice of the banana, you will see it's kind of like a little disk, right? So then I can find the volume of this disk and then try to add them together. So that is what, that's what we try to do. So how do I find the volumes here? So for example, for this slice, we cut it, right? So what is the volume? So we know the volume will be what? The volume of just this little piece what is the volume will be here? Will be the area of these little pieces here. We said xi star, right? Then times the what? Times the height. Correct? Times the height. That's how do we, or the depth of the, your whatever the volume you try to do. So it's the, so in here, that's why we cut a little pieces here. So the depth here, oh, the height of this little disk is will be what? Will be delta xi here, right? So now that's why, so the total volume is here, right? So if you continue slice it, so what is the total volumes here? So the total volumes will just be what? You add all those little slices you cut. So just like example, if we do experiment of cutting bananas, right? So if you cut this banana into 20 little pieces, then each pieces you can find the volume, each pieces of the banana were very close to like the cylinders, right? So you can easily to find the volume. So the total volume of this banana will just be, you add all this 20 pieces, the disc together. So here is the same way. So the total volume for this solid will be what? Will just be equal to is the I from 1 to n. So if you cut into n pieces here, then for each pieces, you have xi, the area of that pieces, times the what? Times the height of these pieces, right? So this is the delta xi is the height. So this is this is kind of like the very similar like the lemon, the Raymond sum concept, right? So the limit of the sum, so the in here, then so the finally, so we know if you take the limit of this sum, okay, so that's why we can find the volumes here is just like a Raymond sum concept when you cut like a the axis into the very, very small pieces here, right? So in here, we will let what? That means if assume you can cut into infinity numbers of the slices here, correct? If you can cut into the infinity number of the slices, and then you will be able to find the volume. So in here, we know that when the limit approach to n, so basically it's what you're integrating here. And then here will be the area formula. So because we are doing the integration, so delta x will become what? Will come to the dx, right? Then what is the, what is the boundary we're going to do? So we have A and B because this solid is between A and the B's, right? So we will have A and the B's here, all right? All right, so this one's here is pretty, okay, so it's kind of the concept is pretty easy. You just slice it. So you think about the experiment, you want to find the volume of a banana, right? You can just cut the banana into the many slices you want. So one of the things I want to put here, the key, is the concept is pretty easy, but sometimes the real application problem is it's kind of not, we need to be very careful here. So one of the keys here is, when you do that, I would recommend you to put the things into a coordinates plane through here. So in here, we need to, the x-axis must be positioned carefully. Here is the key to the success here. So that the function, AX, right, can be determined. And integrable. So you need to be careful. You don't want to randomly put the x-axis here, right? Because you want to be able to, when you slice it, you'll be able to easily define what is this, what is this slice, right? So what is this slice and what is the AX function, and is that AX function is easy to determine or not? And it's also easy to integrate, right? Okay, so now let's take a look here. So let's take a look at the first examples here. I want to find the volume of the 1 meter high, right? So 1 meter high, the cone with the base diameter is 2 meters here. So this is the base of diameter. And so in here, say, I want to find the volume of here. So what are we doing here? So we say, okay, so let's put these cones here, right? So this is my x-axis here. All right, so this is my x-axis, this is my origins, right? So now in here, take a look here. Okay, so like in here, so you want to find it. So in here, you see here, that's why I'm slicing this way here, right? So this is my slice, right? So this is my little disc. I'm slicing here, correct? Okay, so the volumes here, right? So this is a disc, right? So what is so from here to here, right? So this is the what? So this is the axis here, right? So I know the AX here, so I can say the AX is equal to the pi r square, correct? So it's equal to the pi r square. So the area will be pi x what? Pi x square here. You see that? Okay. So now the volumes here. So now this one's here, because each one, this is the pi x squared, depends on what is the value of x, right? So what is the volumes here? So the volumes here will just be, so this is from 0 to 1 and the pi r squared. So this is AX, right? So this is my area, right? So this is the area. So this is the AX, right? And then you do the dx, right? So the dx here. So this one is pretty easy. So we know the area, the volume here is pi over 3 here. Okay, and now the second one's here. Let's take a look. This one's here. Okay, so from your geometry time, right? So when when your geometry time, you all know the volume of a sphere is the volume of this ball, the sphere is V equal to the 4/3 pi r cubed. So here, from the geometry we took, when the time we took the geometry, we took it for granted. We said, okay, that's the formula we try to remember. Okay, now let's take a look. How do I use the calculus to verify it? Okay, so the first thing here, see here, I already drew that, right? So this is what I'm slicing it, right? So I'm slicing this sphere. So every time I slice it, did you see what I come out with? I come out is circles, right? So this little pink one, that will be my circle. That will be my little disc. So for these circles here, and take a look here, this is what? This is my, this part, this is my R, correct? And then I put the x-axis here, y-axis here. So this is the R, and the radius, this is my radius for this little slice. Then the radius for this sphere is r squared, and is r, and I know the circles here, right? So if this is r, and what is this distance here? This distance here, right? So this lines here from here, this green one is what? Is x here, correct? And now, because this slice is going to touch this sphere, so I know it will be circle. So what's that mean? That means x squared plus y squared is going to equal to what? Going to equal to the r square, correct? Okay, so now I'm going to find the, so this will be the radius, y is the radius, right? So for this slice, I cut the pink one. So I can simplify that. I will say y squared is equal to the r squared minus x squared. So I can say y is equal to the square roots of r squared minus x squared. Correct? So this is what? This is the radius for this little slice I cut. Okay, so now let's see then what is the area of this. Let me color code that. So maybe you will be able to, so let's see, this is the pink ones here, right? So this ones here is a pi r square. What is the pi r square? What is r? R is y, so it's a pi y square. So this will be the pi, and the r, y is the square roots of the r square minus x, right? So this will be r square minus x square. All right. Okay, so now I'll be able to find the volumes here, right? So I say, okay, so the volumes will be, right? So ax, so it's a pi r square minus x square dx here, okay? So the dx. Now I'm going to look for the x values, right? So this is green one is my x, right? So x could be from, so when you're cutting, right? You're cutting from the little slice in here, then later you probably will have a slice over here, right? So the x can vary from what to what. The x values, right? So this solid is end up at the negative r to the r. So my integration region will be the negative r to the r's here. All right. So in here, because this is an even function, so we can just do one side. So it's times 2. So you can do just 0 to r and the pi r square minus x square dx. And this is a pretty simple, the integrations. And so if you do the integration, you will find that this is 2 pi. Then you put the up limit minus r cubed 3. So what is the answers here? The answer is 4/3 pi r cubed. And that is what we learned in the geometry time. So we remember that. And now with the calculus, wow, we will be able to what? We will be able to prove it. That's pretty cool, right? Okay, so now let's take a look at this one here. Number 3 is here. The number 3 says find the volume of this right triangle. All right, the triangle solid is 1 meter, 1 meter, and 2 meters on the edges here. So this is 2 meters here. Okay, so now let's try to find the volumes here. So first I will say, okay, let's try to put it, let's say this is my x-axis, right? So I put this is my y-axis and this is my z-axis. So now I'm going to slice, right? So when I slice it, so let's see here. So when I slice it, I'm going to always cut a perpendicular to the x-axis here, right? So I'm going to, let's do here, I'm going to slice this way, okay? So, okay. Okay, so this is, so let me color here. So this little triangle piece is the slice. I'm just sliced, right? Okay, so after you do that, right? So first I want to find the area of this pink ones, right? So I will say, okay, let's see here. This is my H, this is my B's, right? So in order to find the area of the triangle, what I need to do, I need to base times the height. So now this is come to say, okay, so how do I do base times the height? Okay, so now take a look here. So this one, we use this, a lot when we we're in the calculus 1 doing the related rate problems here. So now I want you to take a look at this triangle. So just look in the 2-dimension, this triangle, the green one and this little blue one here. Okay, because I want to find the height and the base, right? So I will say, okay, so the little ones here, right? So the little blue ones here, this this base is this height here, right? So the base is here. So you will say, okay, so I can say this is the 2 minus x, right? Because when you cut it, you don't know what is the value. So this is your x value. So I'm thinking about is 2 minus x is the length of what? Is the length of here, right? So 2 minus x, right? By the similar triangles here, the 2 minus x, this is the blue one, is equivalent, it's equivalent to what? The green one, the big one. So what is the green one, big one? Is 2, right? So then in here, I will say, in here now, the height is this one's here, right? So this blue one, so it's the height and corresponding to the green one, what? Is 1, correct? All right, so now I can do here, so I will know, so the 2h, then you do a cross product is 2 minus x, so the h is equal to 1 minus what? X over 2, correct? All right, so because h is equal to the 1 minus x2, look at these big triangles, right? So they are, the here is 1 meters, right? So this is 1 meter, and this is 1 meter. So I know the h and the b, so they will be equal also. So if h equal to 1 minus x, so what is my b's here? My b is the same, is 1 minus x over 2, right? So now I can find my area. So my area is 1/2 what? It's 1/2 base times the height, right? So it's 1 minus x over 2 times 1 minus x over 2. So this will be 1/2 1 minus x over 2 to the what? To the squares, right? So this is what we just figured out. Let me color coding that, right? So this AX is this little pink area. Okay, so now after that, and then the things become easy. So I'm going to do the volume. The volume will just be AX, so it's 1/2, and this is 1 minus x over 2 to the square dx, and I am integrating to the x, right? So this is my x. So the value of x, because this side, what is the value of x? X could be from 0 to what? 0 to 2, right? Because this side, the length is 2. All right, so I assume, I think this is a very, very simple integration, and I'm not going to spend the time try to just carry out the integration. So assume you know how to do that. So this will be 1/3. All right. So this is what the we call this a slicing methods here. All right. So now let's take a look at the next one. Let's give a little bit of bigger space here. Okay, so the next one here we talk about is the volume of the pyramid, and whose base is a square. Okay, so with with side is L, so that means this is what? This is L, right? So you have a square base, and the height is H. So for this pyramid, I flipped it. So I put this ways here. So this is my x-axis. So the x-axis will go through the center of the base. Of course, you can do the same thing if you put the pyramid, you can do like this. You can do the pyramid like this. Okay, so you can put it like this way. I don't know, right? You can put it like a x, y. So you can let it stand up, right? So to the y-axis, so it will be the same things here. I think the flip over is easier to take a look here. Okay, so now I'm looking at here, right? So in here, after I sliced it, okay, so I want you to pay attention to the, after you do that, so here, I want you to take a look at the triangles here. So maybe I can put that triangle outside, maybe. Okay, so it's maybe easier. So this is the here and in here. Okay, so here we go. So this is the height, right? Because I put it in here. So this is the h. And now I have a triangle here. Oh boy, this one is not. Okay, so here. Okay, so I have a triangle here. Okay, so for this triangle, remember here is the L, right? So this line is the L, and now I cross here, right? So this is my cross, right? So I slice it here, right? So I slice in here. So here is my X values, right? So here, this is my X value. And then because of here, right? So what is here? This is my side, right? So that's why I will say this side is the what? It's X here. So now I need to find this areas, right? This square areas here. So let's see, how do we find it? Okay, so I'm still using the similar triangle. So the X is here, right? So X X is here, right? So now you do so you will say X, right? Over compared to the H, the big triangles, right? So the big triangles here, let's make sure so this is my big triangle. This is the green ones, right? Just we did it before. This is my big triangle, and this will be my, let's see here. Okay, so this will be my small triangles here, right? So I want to find the side, right? Because in order to find the area of here, I need to know the side, then I can find the area. So the X over H, right? So X compared to the height here. So this distance compared to this distance will be equal to what? Will be equal to the whole things here is S. So this is S over 2 compared to what? L over 2. All right? So this 2 and 2 can cancel. So it will be just S over what? S over L here. Now in here, so what is the S here? So the S will be the L times X divided by what? Divided by H. Am I right? Okay, so now the area will be, so let me color coding that. So the area is this pink area we want to find. So what is the area? Because this is the square, right? So we just know the area will just be the S what? S square. So what is the S square? Will just be L square, X square, and H square. All right, so now the volumes here. Now, after we do that, it's pretty easy. It's AX, so it's L square, X square, H square, dx here, right? So that's why I put the x-axis here, because it's easier. Okay, now the x is from here to here, right? So what is the range, the boundary of x is 0 to what? 0 to h is here. And also, this is a pretty easy integration. You can move the constants out. This is h, this is x squared dx. I assume everybody can do that. So now here, that's what is the integration. So that will be the volumes, right, for this parameters here. Okay, so all right, let's take a look at Number 5, see here. This one is very interesting here, right? So it's pretty easy. You just, if you be able to see that. Okay, so let's say this cylinder, this wedge of the cylinder is cut by this the radius here, it's a 4. All right, so this cylinder, the radius here is a 4. And so you cut this one into a 30 degrees angle, and then you cut the bottom. So you turns out to have this wedge here, right? So we want to see what is the volume of this wedge here, right? So this is the pink, the whole thing. This is the volume of the wedge here. So we do the same thing. I'm slicing it, right? So you boom, 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 you slice that. Okay, so now in order to make the things easier, let me move that slice out here, okay? Okay, so in here, so this one's here is the, okay, so this one's here is the x-axis here, right? So put the x-axis here, this is y-axis here. Okay, so you move this triangle out, all right? So let's move this triangle out so it'll be easier to see. So for this triangle, right, so this is A, B, and the C, right? And because this plane cut it in the 30 degrees, so this is 30 degrees here. Okay, so AB here. So okay, so in order to find the volume, I need to find the area again. So I need to know the base, right? AB. So what is AB? AB, look here. Here's AB. But here's my x-axis, right? So my AB really is what? It's the value of what? Value of the y, correct? And also because they are, you know, the x and y, they are in this circle. So I know, so if this is the y, this is the x, right? So I know the x squared plus y squared is going to be on the circle, it's going to be 16. So I want to find the base. So y will be equal to the square root of the 16 minus what? Minus x squared, right? Now the next thing here, I need to find the height, right? So because I need to find the BCs here, I need to find this height. Right, so if I want to find this height, then I can find the area. So what is the BCs here? Okay, the BCs here, this is the height, right? The BC is the opposite side for the 30 degrees. So I know the tangent 30 is equal to the opposite over what? Adjacent, right? So it's BC over what is here? It's y, right? So it's 16 minus x squared. And I know the tangent 30 is what? It's 1 over what? Square root of the 3, correct? All right, so now you do the cross product. So I can say the BC is equal to what? Square roots of 16 minus x squared over the square roots of the 3, correct? All right, so now I know my area. My area here is the same, this pink area, the triangle area I'm trying to find. So it's 1/2 the base. Base is 16 minus x squared times the height. Times the height is the square root of the 3 over 1, 16 minus x squared. Cool, right? So now you will have the what? You have 2 of the square roots of the 3. The square roots of square roots cancel is 16 minus x squared. Now the volume is very easy. So it's ax, right? So this is 2 of the square roots of the 3, 16 minus x squared dx. So correct? Let's take a look. Where is the x going to go, right? So like we said, this is the x here, right? So this is the x here. Be careful here, right? So this is the x. So you cutting. So this triangle can go all the way to here also, right? Correct? So that means the x can vary from what to what? -4 to the +4. See here. Okay, and then because this is the even function also, you can really just 2 times, you don't have to do that. Then from 0 to 4, then this is 2 of the square root of the 3, 16 minus x squared dx. And this is a pretty simple integration also. So you will get the answers here. I'm not going to carry out. I think everybody should know if you are in the calculus 2 class, you should be able to know how to do this simple integration. So that will be the volume for this wedges here. Okay, let's take a look at the last problem here. So the last problem is here. All right, so they said this is the figure for a circular base. So that means the base here is the circular. And then if you do a cross sections, right, to the x-axis, you will give you equilateral triangles here. So this pink triangle is equilateral triangles here. All right, so now let's take a look. How do I find the, how do I find the x and what do I find the areas, right? So first, okay, so let me move this triangle outside. All right, so maybe it's easier to see. It's an equilateral triangle. So I have A, B, C here. All right, so this is A, B, C, right? Because this is x-axis. So what is my drawing terribly? So it should be perpendicular. Right, so now the x is here, right? So that means here is y and the y, right? That means this will be what? This is my y, this is my y, correct? Okay, now because equilateral, so I know this is 60, this is 60, and this is 60 degrees. Okay, so now let's do the same things here. Because a, x and y is in the circle, so we know x squared plus y squared. What is the radius of this circle? Is 1, right? So we do the same thing. So y is equal to the square roots of the 1 minus x squared, correct? Now the AB here, remember this is the y, right? So the AB, so I know the base of this triangle is 2y. Am I right? So this will be 2, the 1 minus x squared. And then now I need to find the height, right? So if I want to find the height, so the height here, right? So the height here, this will be, so if this is equilateral, then this half of the circle will be what? Will be 30 degrees. Because this is equilateral, right? So the AB is 2 of square roots of y. So what is this side going to be? This side is 2 of 1 over 1 minus x squared. And so based on the 30 degrees, 60 degrees angle, so what is the height will be? Height will be what? 2/3, not 2/3, square root of the 3 over 2 for the hypotenuse, right? So it's the hypotenuse here because based on the 30, 60 degree. So we know this one is 1/2. So height will be square root of the 3 over 2 of the hypotenuse. So this is square root of 3 over 2. Then the 2, this is 1 minus x squared. So what is my height? My height is the square root of the 3, 1 minus the x squared. Right? So good. Okay. So now I have the height, I have the base. Now I can find my AX here. My area will be the base. So base is 2, 1 minus x squared times the height. 3, 1 minus x squared times 1/2. Right? Okay, good. So this one cancel. So this is my area is 3, 1 minus x squared. Now I can find the volume. So the volume will be AX, right? So this is still, let me color code that. This is my AX, right? So will be the AX. So this is 3, 1 minus x squared dx. Okay, let's take a look. What is the value of x? Right, so this is the x value, like we say. So the x is from here because this is x-axis, right? So x can go all the way to 1. Also, you can cut here. That's what I show you. You can cut this triangle. So x can go all the way to where? -1, right? So then you can say it's -1 to 1. Then you can do the same way. This is an even function. So you can say the volume is equal to 2 times. Just do 0, 1. 3 to 1 minus x squared dx. Like I said, this is a pretty simple integration. I assume everybody know how to do that. And then the final answer will be 4 the square root of the 3 over 3 after you carry out this pretty simple integration. All right. Okay, that's it. So that is our part 1, and find the volume of slicing. And the personal, I think it is a kind of I think a slicing method is a little bit harder than our next topic. When you're rotating, is and but I think that we talk about the key things here when you try to do the slicings here, right? So the key things here, you need to make sure you very well position your x-axis. So, then you will be able to find your area, this little, the axis areas will be able. So like we always use the pink, right? So this little axis, this little disc will be easy to find. All right, that's it. Okay, so this is we did like a 6 example to show you for any given solid, how can you use the slicing methods here, try to find the volume. All right, and nice talk to you, and looking forward to talk to you our next topics here. Okay, bye.